out on Skill Builder 7.2. We're going to do 3 of those together and cross the rest off. So anything we cross off, just know you're not responsible for. So in our notes, go to 7.2 right here. Same with those of you, if you're not here and you're watching the video. We are going to do just 3 of them in here. So number 1, we're going to do, just to review yesterday, this whole chapter is on what's called a differential equation. It means you're going to be given a derivative. It might say dy dx equals, it might say y prime equals, it might say f prime equals. In this case, it's a word. What word in this problem indicates that this is a differential equation? Slope, yeah. So it's saying if a curve, which a lot of times we call f or y, has a slope, that'd be f prime or y prime, of 2x plus 3, it says which is an equation for the curve. So I'm given the slope, I want to go back to the equation. I want to undo my derivative. That's easy to do on this one, because if my derivative is equal to 2x plus 3, how do I undo the derivative? Integrate, yeah. The antiderivative of f prime is just f. So this would be 2x squared over 2 plus 3x must have been my original curve. So out, out. How do I decide between the other 2 that are left? The point. Yeah, it tells me when I put in a 1 for the x, it has to spit out a 2 for my f of x, which means my Carl right here is going to be 2 equals 1 plus 3 plus Carl. So what's my C value going to have to be? -2, and it locks me into D. Okay, so that one I want you to do. The next 2 you can go ahead and cross off. So, and you don't ever have to do them. So we're going to take this guy off. We're going to take this guy off. Our next one up is number 4. We'll do together. So just some stuff from yesterday. It says, which is a solution to the differential equation? You're eventually going to learn how to solve them. But I'm going to take you back to like the 5th grade. If I were to put this up here, and if I were to say, which one of these is a solution to this equation? Before you were taught how to solve it, you would just plug them in and see which one gives you a 7, correct? And then you get taught how to solve it. So we'll eventually learn how to solve these things, but for now it just says which one's the solution. So to be a solution, it means when I do y double, subtract 4 times the y, I have to get a 0. So what I'm going to do right here is do y prime, e to the u du. I'm doing y prime because I have to get to y double. So then I'll do my y double, right? Some derivatives, e to the u du, so times another 2 in the middle will be a 4. There's my y double. So this is a solution if my y double, 4e to the 2x, minus 4 times my y, which was e to the 2x, equals 0. So is letter A a solution to my differential equation? Yes. You could test the rest because it says check all that apply, but we're not going to. Okay, all you do is just, if they work, it's a yes. If they don't, it's a no. Right? Fairly straightforward. You can cross out 5. Never do it. You can cross out 6. Never do it. I had your assignment on this in AP Classroom. So if you were absent yesterday, that's the points going in my grade book. We'll do number 7. And then you can cross off 8. Okay? So number 7's a good one. And again, usually this is just the big thing for this chapter is what we do in the next 3 days. These first 2 things are little things, but you might have one multiple choice question like this where it says, for what value of k is this a solution to this? How do I know this is a differential equation, by the way? What do you see in there? We're like, that would be called a differential equation. Right here. This is not. This is. Why? The double prime. Yeah. There's a whole course, actually. It's usually Calc 4. So Calc 1 is like we do in AB. Calc 2 is like what we do in BC. Calc 3 is called multivariable, so that's where my seniors in BC will go next year. Calc 4 is usually called differential equations, which is what we're working on right now, but they do so much more with it. So this guy's called a differential equation. I want to know what value of k will make this be a solution. So my y value I know. It's e to the negative 2x plus k e to the 4x. All I'm doing is replacing my y with what it says it is. Then I have to subtract y double over 4. So off on the side, I'm going to walk myself to y double, right? So it's e to the u, du, and then it'd be plus constant stay put, e to the u, du. Am I doing my derivatives too fast, or they're easy, right? I'm going to walk myself to y double, so again, e to the u, du, plus constant stay put with the 4k, e to the u, du. All right. Before I plug it in though, that's my y double. I'm going to divide everything through by 4. So my y double over 4 would be just e to the negative 2x. 4 will cancel. And then a 4k e to the 4x because a 4 will cancel. Are you good with what I'm doing? You following me? All right. So I'm going to go over here and I'm going to replace that y double prime over 4 with what I just got. So I'm just equating the two things. I want that to be equal to 5e to the 4x. So I'm going to repeat what I did. I'm forcing it to be a solution, so I'm forcing it to work. To get it in here, though, I had to go calculate this piece of it, which is in the parentheses. Now I'll just go and see what happens. Those are going to cancel. It looks like I get a k e to the 4x minus a 4k e to the 4x. That I have to balance out with this side. All right. What am I going to do on the left? Combine. Yeah, I have 1 of those minus 4 of those. I have negative 3k of those that equal 5 of those. So really, it boils down to me equating the coefficients. So what k value will force the solution? Negative 5/3, right? So that's what I needed you to get out of yesterday's for the most part. All right? Today's on slope fields, so what I'm going to do is go show you sort of what a slope field looks like first. Then we're going to practice making them and reading them. We're going to be in and out of the notes in this work packet. Last hour we left with only 2 undone in the skill builder. So a lot of the time will be in the notes today, but head back to whoops. All right. So what a slope field is, I'm going to erase this. So edit, clear ink. All right, go to this page right here. And we're going to kind of putz around in the notes a little bit and then leave them. All right, so go to your notes. All right, I'm going to give you a really easy what I call differential equation, which means I'm going to give you a derivative that you're going to easily be able to tell me what its solution is. And when you find a solution, you're finding the original function. So when we go word problems, it might be the rate that COVID is spreading over time is directly proportional to the amount of people who have it. This would be called a differential equation. I'm giving you the rate that COVID is spreading, correct? As a function of the top variable. When it says to solve it, it means I want to know how many people have COVID at any given time, not how fast it's spreading. So to solve it always means give me the top variable. Does that make sense? Whether it's dy, dx, dc, dt, we might do the rate that bacteria is spreading over time. When it says to solve it, what are you finding? How much bacteria there is. You're undoing the rate. Here's one that's really easy to do. Because if my derivative was twice x, what must my original function have been? X squared, right? Plus what? C. This would be called the solution to this differential equation. If I asked you, though, to do that very same thing with this one, you'd be going, I don't know. Correct? But you will know how to do that tomorrow. You don't today. What we do when we make a slope field is we get a visual for the solution. by sketching all the little slopes. So don't do anything on your notes right now. It's a lot of watching today. I'm gonna go to this one, and I'm gonna go back to my dy dx equals 2x. What I would do to make a slope field for that is I would ask myself first, what makes this equal to 0? What's the answer to that? 0, correct? Anywhere x is 0, the derivative is 0. So my function would have a horizontal tangent line. Technically all down this axis, but only do it on the bullet points. All right? When x is 1, wouldn't the slope everywhere be 2? Right? So I'm drawing little slopes of 2. When x is 2, this is what I mean by it's easy, but it's boring. When x is negative 1, well, the slope is negative 2, and then negative 4. I just drew my very first slope field for you. Was that easy? Yes? When you squint at it, you should see the solution. When you squint at this or plop in the slope field and start to follow these tangent lines, do you see the parabola? That's what's happening with the slope fields. You're making the tangent lines, and when you look at them and squint, you should see the original function. On the bottom of your notes, I'm going to have you write what I find to be really helpful. All right. Whether you're making one or interpreting one, the first thing that's always helpful is wherever the derivative equals 0. It's really helpful to consider those first. So for example, don't write this down. I'm just going to give you a for shits and giggles here. If I had x times x minus 2 over y, what would make that derivative equal to 0? X equaling 2 or x equaling 0, but then y couldn't be, correct? So if I was doing my slope field, everywhere along the line x equals 2, I'm going like this, correct? Everywhere where x equals 0, I'm also doing that, but I wouldn't do it right here, because we can't have 0 over 0. But finding where those horizontal is super important. Next thing I do is I look for symmetry, and I'll tell you how you decide. And then I'll show you what I mean. If your derivative is just some function of x, x squared plus sine x, or e to the x times cosine x, or there's only x's on the right hand side, what you're going to have is vertical symmetry. I'm going to go show you one of each of these in just a second. Vertical symmetry. What I mean is, if there's a 1 here, then this 1 here, it'll be the same vertically all the way down. And the same thing, if it's just a function of y, means they're not mixed, you're going to have what I call horizontal symmetry, which means running across the horizontal, they'll all be the same. If they're mixed, no symmetry. Look at this guy. Do you see how right here it's x and y in here? So when we go make it, we're not going to have a symmetry shortcut. Go to your homework packet. I'm trying to flop around so you can kind of. So go to your homework packet, and we're going to go look at number 1 and number 2. Because number 1 is just a function of x, and number 2 is just a function of y. Those you can make super fast. But first of all, I'd ask myself, where is this 0? And you would say at x equals negative 1, correct? So I would draw those first. At x equals negative 1, I would go like this, this. I just killed off a whole bunch of them. Okay? Do you notice it's that vertical symmetry right now? When x is equal to 0, what's my slope going to be? All down that vertical line. 1. So that allows you to, and make sure you do kind of like a 45-degree angle. I'll tell you how they get corrected later in the lesson, like how you get scored on AP for if you have to draw one. Anywhere x is 1, you're going to be just a little steeper. So I told you, they're annoying, they're boring, but they were just fine with it last hour because it's what? Easy. So 3, so I'm just making these slightly steeper. and then I'd be at 4 right here, and this is what I mean by vertical symmetry. I'm not having to think. Once I have one of them, it runs all the way down the line. So when x is a -2, I go -1. So right at a 45-degree angle. And then at -3, we'll be at -2, so a little steeper. That is your first constructed slope field. How was it?
Nice.
All right, right? Now they'll also ask you to sketch a solution, and they'll give you a specific point. So if it said to sketch the solution through the point 1, 1, you go put a dot right here. And then actually in meteorology, these have little arrows for wind currents. A lot of times you'll see it above like oceans and stuff, like how the winds are blowing, and sometimes if they call it a vector field in certain areas, that's what causes like cyclones and stuff. But I always like to say a feather plops right here and the wind starts to push it. It's gonna push it down, then it's gonna go horizontal, and then up, correct? And if I put it here, it's gonna go up steeper. That black thing is called a solution curve. What's it called? Solution curve. All right. You go draw number 2. It's easy because it's going to have symmetry. And again, how do I know it's going to have symmetry? Just Y. Yep. So it's going to have horizontal symmetry. It's going to start with Y equaling 0, having all of those horizontal tick marks. You go make the rest of it. When Y is 1, all your slopes will be 2. And then 4, and then 6. So just steeper and steeper. Is it hard, Amelia? No. Not yet. And actually, slope fields don't really get hard. One type of question is, but for now, that should be super easy. How are we doing? All right, so the next thing I'm going to do is say, well, what about down here? We're going to skip this guy, so go ahead and cross that one off. If I cross it off, you never have to do it. If I don't cross it off, you finish it at some point. All right, for this one, it's going to be a little different with number 4. Number 1, there's no symmetry. That's its first deal, correct? Number 2, I got to be a little bit careful because when these get graded on the AP, they're almost always worth 2 points if you have to draw one. One of the points is almost always for you getting the zeros locked in correctly. All right, so where would this derivative equal 0? Anywhere where what 0? Y is 0, correct? But I'm not putting 1 in the middle. Why not? Because 0 over 0 is undefined, so you can't put 1 there, okay? Anywhere where x equals 0, I'll be dividing by 0, correct? We know those make vertical lines or undefined slopes. They usually don't want you to draw those. You're just supposed to visualize. I like them drawn. You won't get docked. If you watch the AP video, they're going to tell you not to draw those. I kind of like to do it. I did it in black so that maybe they can't see it, but I like to see a vertical asymptote there just because it is. All right, the other points you are going to start sketching. I like to start over here because I'm good with positive numbers. So I start here. So I'm going to go at 1, 1. What would my slope be? -1. Make sure you go at a nice 45-degree angle. Okay? At 1, 2, it's going to be -1/2. So I'll just be a little bit more gradual than that one. And then at 1, 3, even more gradual. Actually, that's a little too much. All right? Next up, at 2, 1, I'll be at -2. So a little bit more steep. And then At 2, 2, I'll be at -1 again. And then at 2, 3, there you go, 2/3. You go ahead and start sketching that sucker out. It's going to start to look like something. I'll find somebody who has a nice sketch. I hate sketching. Some people like to make tables too. Like they'll do an XY table and go pretty figure it out. I think I'll find it. You're basically doing arithmetic and making little lines. Well, now you're starting to recognize a pattern, right? I like it. Ella was seeing, well, this is going to be -1 all down that line. So, -1, -1, -1. She just killed off a whole bunch of them, right? Then what did you do down all this line? Yeah, exactly. So you start to see some patterns. I'm not going to finish it. Why? Because I find it boring. Yeah, I do. You just have to do arithmetic and make little lines. I will tell you on the AP exam, you don't have to do as many bullets. So I'll go show you kind of what they look like. Can we quit with that one? Okay, we're gonna bail on that one. You finish it at some point. I'm not gonna cross it off. All right, next thing I'm gonna have you do is flip your work packet over, and I have the actual 2010 on the back. So you can see how they do it. So flip it over. On the back, we're gonna be all over the place. On the very back is a 2010 actual FRQ that deals with this chapter. So I gotta get past our exponential growth, the potato. Your very last one. That's not it though, is it? It's not a copy. That's your second to the last one. We'll go on to. Anyway, go ahead and look at number 5. You see it? Part A says, on the axes provided, sketch a slope field for the given bullets at the 12 spots that they have on there. They have 6 up above, 6 down below, correct? So way fewer places on the very back of here. First thing you're going to do is ask yourself, is there symmetry, yes or no? No. Is there a place, though, that's always going to have a slope of 0? At x equals what? You're going to kill off 4 of the 12 right there. Correct? All down your x equals -1, you are going to go boom, boom, and then they don't have a bullet there, boom, boom. That will be 1 point usually. It will say student has the zeros in the correct spot. All right? The other ones get graded in reference to the zeros. So if you get a slope of 1, you do need to make sure it looks like 1 and that 2 looks steeper, but nobody goes and measures them. Does that make sense? So you go finish that one. I would do the positive ones. I do 0, 1, 0, 2, 1, 1, 1, 2. Do you see how much easier it is because I have fewer bullets? Are you done already? Can I steal it? Okay. Looks like it should look like that, and then steeper, and then the same as the one above it, and then, did yours look like that? Somebody else? Yes? What do you think? Or did she do it wrong? You're not answering me. Is that what it looked like over there, guys? Yes? All right. So how would you get graded? 1 for the zeros being in the right spot. Your second point is that you do all the bullets, okay? And that these look good with respect to each other. So if this was at 1, then was this steeper or more gradual? Was it? I think I might have sketched yours wrong, but it doesn't particularly matter. So we are good with how to sketch them. Now I'm going to go back. All right, we're going back to the notes. We're all over the place. That's okay. It went well last hour. I do this chapter different every time. So next up, back in your note packet. A solution to a differential equation is what we're going to talk about next. So we're going to go to this guy right here. Back on your notes. Back to this one right above. We are going to go sketch this sucker, or part of it. Okay? So again, for part A it says, we are going to sketch it. I would put zeros everywhere X is 0. Boom, 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 boom. Why am I not putting it at the center? It'd be undefined, correct? Anywhere where Y is 0, I picture these little vertical guys like that. Okay? Then we're going to just go start creating it. I'm going to tell you, I would go over here in the first quadrant, and I would at 1, 1, we're going to get a -1/2, so very gradual. At 1, 2, we're going to get -1/4, so even more gradual. At 2, 1, we're going to get a -1, so about a 45-degree. And at 2, 2, -1/2, so a little more gradual. There's my first quadrant. If you were to start, you're going to see that there's some symmetry here, and it's going to kind of go like that, so where that, you would notice that as you go. You go fill in the left side. -1, 1. Notice I'm kind of doing what Ella was. I'm kind of seeing like little patterns. Are you done really fast? Yeah, like if you start to see patterns like, oh, these are just the opposites of those, that helps you make it faster. So at -2, 2. All right. You should look up there and kind of see that. All right. So a couple things. I've got a couple of these a little longer than the others. You should try to make them the same size. That's one thing. I'm going to go shave off a few of mine. There. Part A is done. Part B, when it says sketch a solution curve, that's me putting a feather right over that, and the wind starts to take it. And if it were to go to the right, it would come down, correct? It would go vertical right here. It'd come around, go horizontal, kind of go vertical. The wind would sort of push it like that. What does it look like? Circular, oval-ish, correct? That black thing is called a solution. What's it called? A solution through 0, 1. I'm going to show you a couple solution curves because you're going to be drawing them. All of these are solution curves. How do you know which one to draw? It depends on where they tell you to put your feather. So if they said put it right here, you would say, well, it's going down and then it's looking like it's curving and they're going that way. So you draw the brown one. It depends on where they tell you. Okay? If they told you to go right here, you're just going to go like that. Agreed? So just so you know what the solution curves, what you're supposed to draw. Here's a whole bunch of them. How do you know which one to draw? They'll tell you, right? Put your feather right here and let the curve take it. All right. Next up, we are moving on to, we're all over the place. Back to your work packet. Back to number 5. Okay. So, there's also what's called interpreting slope field. So it's made for you. You're to match it with the differential equation that made it. I would focus on symmetry and zeros, and usually everything works itself out. Which ones have symmetry? 5, 6, 7, and 8. Which ones have symmetry? 5 does, correct? And which one? 7. This is going to have vertical symmetry. This is going to have horizontal symmetry. Also, the derivative of what is sine, that you know, right? Negative cosine. So you're looking at sort of a cosine when you squint and look at it. And it has vertical symmetry. Which one is it? C. Done. For number 7, it's 0 everywhere where y equals what? 2. So you should have horizontal dashes along the horizontal line, y equals 2. And it should have horizontal symmetry. That settles the deal. Who is it? Perfect. Okay? Between these two, you'll ask yourself, where would this be 0? Anywhere where the y equals the x. So up the diagonal where y equals x. Boom, 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 boom. There it is. I know this one's last by default, so it has to be b, but wouldn't it be 0 anywhere where y equals negative x? Correct? So it'd have the stepping stones down the other. You go do the next one. We're just practicing on your homework just because. All right? So you go do 9 through 12. Somebody sketched them, and they're done. What did they sketch? 11's the easiest because it's the only one without symmetry, correct? So what's number 11 for sure? D. That has neither horizontal or vertical symmetry. Okay, did I give you enough time? No, we're still good. All the zeros just can help you out with the other ones. Correct? Number 9, which one shows zeros at x equals 2? B. Number 10, which one's showing horizontals along y equals 0? Which one is it? Be careful. It's C, correct? A is the x equaling 0. So that's A, that's C. How do we do on the matching? All right. Next thing with interpreting, we're just going to stay right on the work packet here. Now it's not giving you the derivative that made that. It was made from some dy dx equals, and when you squint, you see the solution. So that's what slope fields are. They're a visual for the solution. So if I were to step back and squint at that, are you seeing a parabola? No. Are you seeing exponential growth e to the x? No. That would be like if you looked at it and you're like, it looks like it's going up like that. Are you seeing e to the negative x when you look at it? No. Are you seeing a cosine wave when you look at it? No. Are you seeing the natural log function? Yes, natural log goes like that, and there's even a dot there on that one. So again, the derivative makes the slope field. What it makes is to visual the original. So let's go to our next page. All right? And you figure out which that one is. When you squint at it, somebody's made the slope field and graph the derivatives of all of these. And again, if you kind of truly squint your eyes, it makes a shape. And you're going to ask yourself, is it a sine wave, a cosine wave, a quadratic, a cubic, or a natural log? What do you most see when you squint at those? Sine, cosine, parabola, cubic, or natural log? Cubic. And you're done. It's as easy as that. I'm trying to make this really easy. How's it going? Right? I mean, I'm not doing it like super exact, but we're going to wait on number 15. We're not crossing it up. All right. Next up, we're going to do number 16. Is that the last one in there? There's a 17. Okay. So number 16, it says to sketch it. Let's just sketch it on like a smaller window. Let's do it like AP does. Let's just sketch it. I'm going to need, let's do here. Let's bullet. They usually only have you do 8 to 12. Bullets. So let's cut off a bunch. Let's just do it in here. We'll cut it off a little bit. All right, where is this equal to 0? Anywhere what happens? X equals 0, correct? And anywhere y equals 0. Can I have the middle one on this one? Yes. It's only if it was an x over y, I'd have to delete the middle. So I just killed off a whole bunch, okay? Then I go over here and do my positives, 1, 1. It's gonna be a half, so make sure it's gradual. 1, 2 is gonna be at 1. 2, 1 is gonna be at 1. And 2, 2 is gonna be at 2. So you guys go sketch that out. Are you done? Did I give you enough time? It's starting to form. All right. Next up, letter B. Has nothing to do really with this chapter, but you need the so this would be like FRQE, and then there'd be a part C that you wouldn't know how to answer yet. Okay? So it says let F be the solution to it. You can't find it. That would have been in part C, and that's tomorrow. But it says write an equation to the tangent line to whatever the original function was. How do we write equations for tangent lines in here? We need two things. What are they? Slope and point. The point was given to me. They're saying through this point, 1, 1, what must the tangent line slope have been? Okay, so what would the tangent line slope have been? 1/2. You plug it in, right, to the Diffie Q. It was x times y over 2. You wouldn't get any points yet because you haven't given me an equation for the tangent lines. We'll do that next. Y minus the y you know is equal to the slope there times x minus the x you know. And I would just leave it like that. All right. And then it says to estimate what happens when you put a 1.2 into your function. Where do I put the 1.2? Right here, correct? So my y would equal 1/2 of 1.2 minus 1 plus 1. Would you clean it up? Not unless you want to risk making a decimal mistake or something. You could, and you get it right, but you don't need to clean it up. Last step in that packet, back one, okay? We are going to go start sketching this one as fast as we can. No symmetry, but it's nice and easy. I'm going to have zeros here, anywhere x is 0. Technically, I have little verticals here. The College Board doesn't like you to draw them. And again, why am I putting nothing in the middle? That you can't do. Because 0 over 0, you don't mess with. Now watch the shortcuts. Where would there be an easy place to take a shortcut and get a whole slew of them? What's gonna happen everywhere y is equal to x? You're gonna get 1, right? So let's go put little 45-degree angle ones all along where y equals x. They're killed off a whole bunch. How else could I kill off another 6 of them? -1. Anywhere where y equals negative x, I'm gonna go kill off and make those -1s. Okay? The rest of them, you'll probably start seeing patterns for. Okay? So I'm gonna go start drawing the rest of them. I like to go to the first quadrant. 1, 2 will be a half. 1, 3 will be a third. 2, 3 will be 2/3. It's deeper. -1, 2, -1/2. You can see these are going to be similar. -1/3. What's this? -2. Go ahead and blend. When you're done, draw a solution curve through 0, 1. Go with the flow this way. Go with the flow this way. Do you guys remember what this is called from pre-calc? This slanted line that's kind of blocking everything. It's called a slant asymptote. Yep. And this down here ended up having the same kind of vibe to it, so it's going to go down here as well. You might say, why are you doing that? It's said to draw the solution curve through 0, 1 and 0, -1. I didn't finish my slope field because I'm lazy. You guys need to finish yours, so I'm not crossing that one off. All right. Did we do or cross off pretty much everything on that skill builder? Okay. So your assignment is actually in Delta Math. You're going to be sketching, but only at 4 points on each one, I think, 4 or 6. And they're gonna have you pull the line. So you're gonna have to be really careful. As last hour, somebody right here had a slope, but like I think he had to do it in these 6 places. And it starts you off with one and you have to pull it. And he had a slope of 1 and went like that. Why did Delta not give him a green check? Is it too steep or too gradual? Steep. So you have to be pretty, you can't be as sloppy as I was on these. You have to go at a 45-degree angle. And if the next one was 2, you have to go steeper than that one. Does that make sense? So if this is -1, it should look like your +1. So make sure you're careful in here and you go fast. So what's your assignment? Delta Math. There's 5 sketching, 5 reading. Yep.
Football.
We'll take care of that one together. Don't do anything more in the paper for today.
I've been fighting through sleeping all day.
Just Delta, you should take an 80, 10, 15 minutes unless you're sloppy. Oh, I'm gonna stop this.